Hey guys, what do you think of that animation? Hey Miguel, how's it going? Thanks for joining. Let me know what you think about that animation. I really like how it ended up looking. Like, we will go through it in a bit, like how it looks, how did I get it to do this? But it looks very cool. I like it a lot. I like how it came out. I also like the astronaut just hanging out and just reading a map. So it's very nice. Okay, so let's get to it. So last time I just spent most of my time just like figuring out how I would solve things and do things correctly. Yeah, I really like the countdown. Like the countdown one was like I had this idea last time, like last week. I had the idea of like what if there's like a popping countdown in the screen that tells you like when the stream is gonna start. So the cool thing about this whole thing is like it was done in CSS. So except for the animation for the astronaut, everything else was done in CSS. So let's start with that. Let's just start with the countdown itself. Give me a second. Okay, so let's do the countdown itself. So I also restructured things a bit more to make it more easier. So there is this company that does. So first, let's do the countdown first. So for the countdown is first, it's just straight up CSS for the animation of the let's put it side by side. Yeah, this might be better. So let's do this and then local hold. Yeah, so this is the countdown and this is how it looks. Yeah, so cool. So the way it works for the countdown itself, so the countdown itself, the animation itself, the popping of the animation is pretty much done in CSS. So CSS3 has these animation frames where you could control how the frame itself looks like. So this class here is the one that is doing most of the animation. So you pretty much tell it how long the animation is, and then you tell it like if how linear you want the animation. So you could determine like the different timing of the function itself. So like the keyframes, you could control it there, and then you could control the direction of the animation, and like if you want to like feel like what kind of feeling you want to use for the animation itself, and then like the state of it, so if it's running or not, and then you could continue doing that over and over again. So the animation itself just keeps going, and then you could give it a name, and then with that name you could set up a keyframes. So the keyframes, the way it works is that you kind of could do anything like 10%, which is just pretty much where you want the animation to happen, how often. So in 1 second, the scaling happens in between 1 second, so 500 milliseconds of it. And then there is like the different transformations you could do. Like you could, so the one here is just making the text bigger, but you could have other ones where the text just flips around and transforms in a different direction. So for example, if I change this from 1.5 to 3, let's do 4, and then I refresh, you see the giant numbers. So pretty much the scale, it's just like it just controls how big the text itself is. So that's very cool too. Yeah, the thing that I got stuck the most was like figuring out how to do animations. I got the animation to work, but the thing I couldn't figure out is how to get transformations themselves to work, right? So the transformations themselves only work on blocks. So that was the only thing I didn't understand. It was like, so if you look at the time, if you look at the minutes and the seconds, they're H2 headers, and that means that they're the display. Yeah, so pretty much that. Yeah, so it's pretty much that. It's just like the props. So scale, translate. You could rotate it. You could also use font. So one thing I looked at was using font. Let's just take this off for now. And you could do like font size 40. So you could do that too here. And then it would like change the fonts. So, but the thing that happens is like it turns very weird when you use fonts. You see how it like bounces and pushes out to the side. It doesn't scale correctly. So the suggestion is use something like this here, where the transition is more like linear and less like bouncy all over the place. So that was like finding out like the different ways to transform the text was very helpful. But yeah, so that is like you can only do transformations or any kind of like translation or anything like that if it's a type if the display of the element that you have is a block. So you have inline block and you could only do it with block itself. So that's kind of the way that you would set it up. So like you always have to be done in a block. So that was very cool. So I was very glad that I got that part working. And then the animation itself, sorry, the counter itself is just a JavaScript that I roll, which is using the JavaScript ticker. So the first thing the way it works is that, so you have a variable named minute starting, and that lets you control the time where it starts, right? Oh, that's good to know. Yeah, it's the same. It's the same way. Yeah, so like it's pretty much the same way as if you do with mobile development. Yeah, so for this JavaScript itself that is controlling the countdown, you're able to control you're able to pass the number of minutes you want to wait, and then with those number of minutes that you want to wait. Put up space here. Yeah, so the number of minutes you want to wait. So the countdown itself, you control it from like you could do like 30 minutes all the way, and just starts counting down. The way that the countdown itself works is just use a set interval function that gets called every second, and I'm just like subtracting 1. So every time it ticks, it's gonna subtract 1 from the time left. So it's just in seconds. So I'm taking the 20 minutes and then I'm multiplying it by 60, and then from there I'm subtracting 1 second every time the ticker fires. And that's pretty much how the countdown works. So the countdown itself is just like a counter that is being decreased every second. So every time the browser ticks, it's gonna decrease it by 1. Then there's like the formatting, which is like converting the seconds back into minutes, which is like regular conversion. So I'm just doing dividing by 60, and I want to get a round number. So I'm just like doing floor here, so I could get the latest a whole number, and then I'm finding the mode of 60. So just whatever is remaining, and then this part here is just adding the leading 0. So that's pretty much it there. And then the next part of the JavaScript itself is just like, as you can see, only the one that is changing, which is weird because this is, I might have, yeah, so this is better. So as you can see, the only thing that is changing right now is just the seconds, which is the one that is only changing. So I wanted only the integer that was changing over time to be the one had the animation of coming out. So that's pretty much where this part here comes to play. So that part here, the way that it works is just gets all the minute and the second element, and then just like goes through it to update it, right? It just adds the pop class to it or removes it depending on if the content of the element change is gonna add the pop. If it didn't change, it's just gonna keep as it's gonna remove it. So that's pretty much how it looks like. And if you look at the inspector tool for it, we could see the DOM being updated over time and just like changing over time, and like how fast it's changing over time. So you could see that, which is very cool. So that's pretty much how the animation itself works. The astronaut itself, there is this company that released a set of vectors illustrations for free a while back. So I think like 2 weeks ago. They have a ton of animations. They have a ton of library, like a ton of vectors that you can use. So like you have like a beaker on fire, and you have like roll paper, and then like some cups and things like that. So I thought it was very cool. So here's the astronaut. So I ended up just using this astronaut. Oh, so I'm not using jQuery. This is just pretty much straight up just so if you look at it, which give me a second. Over. Yeah, so I'm just not using jQuery here. This is just directly accessing the DOM through the regular browser API. So I don't have any third-party dependencies in this library specifically. It's just like straight up just going through, just using the browser default. Especially since I just wanted to be able to access the inner content. I didn't have to do anything fancy, so I could just straight up just like use like the class element. So I'm right here. The way I'm using the API is just like document is just like means I'm getting the whole HTML body on the page, and then if I do that body, it's just gonna go into the body tag, and then from there I could do that get by class name. So I could get by class name, or I could get by ID. So that's pretty much the only difference. And then like this has been here for a while. The thing that jQuery does, it hides most of the abstractions, right? So like for jQuery, you could just pass like for class names, you could do that in the class name. For this one, you have to be more specific, right? So if I wanted to access a element by the ID, I have to use a a function named getElementById or something like that. Instead of just using one function to do the work, I have to use like two functions. Yeah, but this place has a bunch of libraries. Multiple animations and things like that. So like the astronaut is in here. So like there's a cow being abducted by aliens. The cool thing I learned is that there is this library that Airbnb created called Lottie or something like that. I cannot pronounce the name for it. But the thing that it does is that it lets you animate SVGs directly from whatever. So the designer could animate it, and then you could export it as an animation. So it looks like a giant it's like you give a giant JSON file. So this is the astronaut. So this is how the astronaut itself looks. So the astronaut itself is just like a giant blob of JSON, which is gonna probably cast my browser. But this is pretty much how the astronaut itself looks like, and it's just like the animation of how it's gonna be animated in the browser. The only thing I learned is that this library that they created works in pretty much anywhere. So you could use it in React Native, you could use it in iOS, and you could use it in Windows too. So pretty much the goal of these libraries, letting the designer go from having designed a vector to animating the vector, and then the same animation that they did, they could export it, and then the developer itself could just take it and start using it in their applications without having to like do the animations themselves. So it comes with all the animations that you need. And the way that the library works is like super straightforward too. So yeah, the way it works is just pretty much simple. It's pretty simple. So it's pretty much the same way that you access elements in the page. So you pass the element to it, and then you tell it how you want it to be rendered, and if you want it to loop, and if you wanted it to autoplay. And then you pass the path to the JSON file that has the animation already in it, and also the object for it. It looks like they fixed the issue with React Native, so if you want, you should look at it again, because it looks very cool. Especially in some places where you want to have like cool animations, and it's very hard to do animations in React Native because it doesn't work in iOS or it doesn't work in Android. You could kind of do it here if you're able to like fake the screen, which is like some of the samples that they have is like how to fake this, like how they fake some of the screens to look like they're doing some kind of animations. Cool. I really like this a lot. It was very cool to see it, and I like that. So these illustrations are pretty much open for any kind of use, and they have some other cool ones. I ended up subscribing to them because some of the other ones look really cool too. So like there is the Adventurer, which I really like, so I just ended up just like getting a bunch of them because I feel like I would just use them for another project. So I like them a lot. So that's the astronaut with the countdown. And then the other thing I worked on was a way for like a standby. Sorry, not a standby. Yeah, I think that's pretty much it. Cool. So maybe let's just jump into what we're going to be doing today. So what we're going to be doing today, so I want to be able to, so one thing that I noticed while streaming last week was like people were following me, but I didn't see the following event happening in real time, right? So it would be cool if there was a way for me to show in the stream and then like get a notification in my headset which says like someone subscribed, so I could just welcome them to the stream, for example. And I was looking at some of the ways to do it, so I decided to use server send events versus WebSockets. So server send events is pretty much a way for the server to send events to the client. It's pretty much the same thing as WebSockets, but the only difference between WebSockets is because WebSockets themselves is its own protocol, and this one is built on top of HTTP. So it will be easier to use across like multiple browsers. You don't have to worry about like load balancers or anything like that, because it's just you're making an HTTP request that is never closed. That's pretty much the way that this works. So it's pretty much almost the same, but it's one direction. So only the server could push information to the client, and the client cannot push information back to the server. So the whole goal will be to just try to build this in Go. I have done it before, but it was like 3 years ago, so I'm not sure how this is gonna end up. But it's gonna be cool to do. So yeah, so the way it works, we might have to change some of our code a bit more, because I want to make sure I haven't I got lost. Cool. So I haven't changed much of the structure of this file from the last time that I showed it. I ended up open sourcing some pieces of this package. Just the HTTP client I ended up open sourcing. So if you want to look it up, if you want to look at some Go, which is like just the HTTP client, which makes it a bit more. It just sets a bunch of default variables that I think are very helpful to have from the beginning. So the only thing I didn't open source was the server itself, which is I'm going to do it probably this week, because there's still some work that I need to do there. So it's kind of lump pulling, but lump pulling, you close the connection and you open it again, you close it and you open it again. But this is like, the connection is never closed. You could think of it like, this is like next level lump pulling. Like the connection is never closed, never closed. Like the way that it works is that when the client makes a request to that endpoint, the endpoint never returns. So that means it only flushes information to the browser, but it just constantly flushes. So it just doesn't do anything like, it doesn't close it and then open it again and close it again. So you could think about it if you're doing like TLS. So if you're doing like encryption or anything like that, the connection itself, every time you open and close the connection, there might be a cost attached to it. In this case, it doesn't have it. Yeah, it's like streaming. Yeah, so it's like it's a way to stream data to the client, and the client itself just like takes the data. So if you look at the API, yeah, if you look at the API itself, it's like you're pretty much telling it to connect to this endpoint here. So you're telling it to connect to that endpoint, and then from there you could see like you could pass credentials if you want, but then you could listen to the events themselves. So you could do like pings and things like that. So for us, it's like I think last time I tried it, the events didn't work correctly, and I only had to do one event. But we could see how it works. But yeah, it's just streaming. Yeah, so even if you look at the headers that you have to pass, it's just like a streaming header for it. So here for us, the only thing we're gonna have to change a bit some of the work. I'm trying to debate if I should bring something like a HTTP router or something like that to be able to handle our routes a bit better. So for now, I'm gonna see if I could just stick with just server mutes and see if I could how far it could get me. So the first thing I want to make sure is that I know the different headers that I have to send. So yeah, so this thing is never gonna close. So it first has to echo the kind of event that it's gonna be sending, and then it's gonna echo the data that it's gonna be sending. And it looks like I have to send back 2 new lines. So okay, and then I have to flush. So this is PHP, so I won't be doing this in PHP, but it's helpful to look at a certain code that does it already for us. So I just have to figure out how to do. I think I know how to do the flushing, kind of. I think I know how to do the flushing in Go, but I will have to probably learn how to do that. And then we might need to use channels a bit, so that's gonna be interesting too, because the way that it's gonna work is that there is gonna be a goal routine. So the goal is to be able to get the new followers. So anytime someone signs up, I want to be able to get a notification saying this person signed up. The way that this is going to work, because I'm not using WebSockets, I will have to go and ping the Twitch API like every half a second, or every minute or every 2 minutes, and seeing that there. Yeah, so it's pretty much for the parsing. So the parsing itself is like, it's just telling the client that this is ending, that the message itself is ending, and then the next message will come in. Because we could constantly send messages. If you look at this, it's just a wild, like it's gonna go forever until it gets to like the counter is 0. So there's no messages, and then it just keeps flushing until it just stops. So that's kind of how we're gonna handle it. So let's see how this far I could get. So one thing I want to try out is, maybe I'm debating if I should start with building the logic itself for handling the request, or should I build the part that handles getting the messages. But to make it easier for ourselves, let's just make the part that handles the stream itself, like the request. So we could fake some requests coming through. Let's see. Type. So I'm gonna make a handler type, and then I'm gonna give it like stream. So the handler type itself, I just want to be able to, here I'm gonna be able to like save the this channel for the client, or not the channel for the client, or the channel to send messages. So I'm just gonna count it like messages or message, and then I'm gonna do chat, and then here it's just gonna be a string. And we will figure out what that string has. So right here, I'm declaring a message value called type. So you're saying that you're seeing, let's see. It does. So it does have an API, but it is a WebSocket API. And then you have to do 2 steps. So you have to do it in off too. So right now, the way I'm gonna do this is that I want to avoid as much as I can having to use a full off. So that means that I have to set up like a local, like the server itself has to be able to handle a OAuth authentication. And then the way it will work is that it will open a WebSocket. So Twitch uses WebSockets for their events. So the 2 choices you have is, well, there is events. So there is like an event API where they do webhooks, which they will post every time someone follows you, they will post into your service. That wouldn't work for us because we are running this locally. And since we're running it locally, that means that we cannot expose it to the internet. So there is no way for the Twitch servers to hit our API. The other one is the WebSockets. But for the WebSockets one, you don't get that much information. You only get subscribers. Like every time someone subscribes, they will post it into the WebSocket. Yeah, so there is something called like Streamlab or something like that does it for you. But again, I want to like build something, so we're gonna be building kind of be building Streamlab, some of their widgets. So there is this that does all of those things for you. So the way this is pretty much the same way that I'm gonna be doing it. The only difference is like, since they're hosting outside, like they have their own hosting server, they are able to get the webhooks into from Twitch. In our case, so I could show you the APIs. So one thing I was hoping for is that the next version of this work would use the WebSockets, but the WebSockets itself are missing information. They don't give you much information here. Let's see if I could find some. yeah, so this hook here, you can subscribe to it and just like post this into your server. It's the one. Yeah, it is. So that's kind of how it will work. But since we don't have a web server that is running externally, we cannot really use the webhooks. And then they have the WebSocket one, which will work perfectly for us, but it's missing information. It only contains like subscribers and things like that. It doesn't contain the followers. So the way it works, there's topics and you connect to those topics. But here are all the topics that you can connect to, and most of them are just like for people that are affiliate or partners. They will probably use this API to see when people are adding bits or when people are subscribing to their channels and things like that. But for now, the one that I was thinking of using is their all API, which just has it's in there somewhere. Yeah, so I'm gonna use that. I'm gonna find it later because we don't need it for now. But the goal will be to just use that API to be able to use it, to just pull it over time to make sure that it works. So that's kind of how like the thing with Streamlab is like it handles pretty much everything for you. You just have to embed the HTML widgets that they give you, and then those widgets will just show up in your stream. So yeah, so we're kind of building that. So the next thing, so here we have our messaging channel. So it's every time we want to post a message to all the clients that are listening, we will use that. Yeah, so there is a rate limit, but the rate limit is like you can make 30 requests per second. So as long as I don't make more than 30 requests per second, I should be okay. And then the next version of the API has like a higher rate because I'm gonna use a token, an authentication token. But for now, I don't need it. So okay, so we have the messaging. So we have the message that we will be posting in, and then we need to have a list of clients. So the list of clients. So usually there's only going to be one client connected. But I want to make sure that there is more than one client. Like we're able to handle more than one client. So we have to make sure that we have like a nice like set of configurations for those clients. Give me a second. So I think for the clients, I'm not sure if for now I'm just gonna do. I'm gonna just add a channel. So in Go, you could just do type channel. So you could do like something like, and then here you could just do Boolean. So that means like what I'm doing here is that so for each client, I'm gonna create a new channel, right? So it's a channel that the client itself is gonna be listening on. And then so it's gonna look something like, let's just start building that too. So we could do something like handler, and then here I'm gonna do something like run. And in here, I'm gonna have a for loop. So we want to constantly run this. So here, so this is how you do for loops in Go. So it's saying that it's gonna run forever because there is no way to close it. So I probably should build that too. So we're gonna have one that says shut down, which is just gonna shut down. So we're gonna use it to shut down the to exit from the while loop. So the way it will work is that first, we're gonna use a select to listen to all the channels, to the different channels that we have. So here will be like, the first one will be like shut down. Let's see. Oops. Let's just message first. So it will be this, and then we're just saying that when the message comes through, we are gonna handle that here, and then right. Or did I make? Oh. There's no need for that. So it will be this. So here. So we're saying if there's a message in the message channel, we then want to go through every client and we want to post that into every client. So we want to loop through all the clients and just like send that message to it. So here we could just do client and then that age and then clients. So we're just gonna loop through all the clients. Let's see, what is that? Oh, it's because I'm assigning. So let's see. Yeah, I'm missing part of it. So I haven't done Go in a while, so my syntax is a bit rusty. So I have a sidebar with like all the different ways to do for loops and things like that. Okay, so here, so this is the message that we're getting, and then this is the client. So we could just call it client. So and then make this even. So the way that channels work is that you could revise information and you could send information through the channel. So because we're going to be doing every request in Go has its own Go routine. So it runs in the background. It has its own it runs in the background. The goal here is to be able to take a message, add a message into the message queue, and then take that message and forward it to all the clients. And to do that, we will have to do like, we could do client and yeah, so client, and the syntax for this will be message. So we're taking the message and then we're forwarding to the client. Let's see. Oh, I've never seen that one before. Let's see. And then the next one, it could be this is another case here, which will be for the shutdowns, right? So this will come through and we are going to pass the shutdown message. And then the shutdown message will be used to just turn off the for loop. The for loop is going to be used to, so we're going to break here. And I think I don't need it, so I could just do this. Let's see. Since you're inside a select statement, you have to declare another variable to exit. And so the way that the else statement works is that it will listen to all the events, and then when one hits, it's just gonna fall through and then go back to the top of the for loop, and then it's gonna go into the select statement again and wait for another message to come into the queue, into any other queues. So we have to exit here on the top. So what I'm doing right now is like I'm just telling it, let's just exit at the bottom. So what I'm telling it is to exit the for loop. So if it's true, it's just gonna exit. So break, and then here, I don't need this. So here it's gonna be exit equals true. So we're just telling it. So the way it's gonna work is that if we put something into the shutdown queue, so if we pass a value to it, it's gonna trigger this case here, and then it's gonna exit. And then when it exits, it's just gonna set the value. It's gonna set the value for exit, and then when it hits here, it's gonna just break out of the for loop, and that means that the Go routine will be killed at that point because we're not using it anymore. Okay, so let's see if this does what we want. Cool. So first, we have a channel to get the messages. So when we put something in there, we're gonna get something out of it, and then we have another one that it just takes all the clients. So maybe here, one thing that will start happening is if we don't manage this correctly, we're gonna have a it doesn't let me. So I try to exit here. So it complains that because I am trying to exit inside of the select statement, I'm trying to exit in the case. there's for some reason it just thinks that this is not gonna work, and I think it's true. It just shouldn't work. Yeah, so like that's kind of the issue that's happening. So this is the easiest way I think I could think of right now to exit out of it. Yeah, you could do go to. Oh, that's a good one too. I could probably use return here. Yeah, you're right. I could use return here. And you're right. It should just return out of it. Yeah, return works. So you could do return and you just like issue exit too. That's a good point. Thank you for that. Yeah, so return will exit. So we have shutdown. So the other thing that we have to worry about is because we're running this in parallel with multiple Go routines. So there is different things taking actions here. We don't want to add clients in. We have to have one point in the code that manages adding all the clients into the map that we have in line 11. So that will be the next thing that we'll have to figure out. It's like, okay, so see, if we don't want a memory leak where, a race condition where multiple things are touching the same object, we want to avoid that here. So we have to create a new one called connect, and then here. So when a client connects, we're gonna trigger an event. We're gonna send a event into the connect channel, and then that will be handled as part of our case. So we could only be touching that map in this code here. So this line here will be the only one touching the map. So here we could do client, and then yeah, so we're gonna connect, and then here, since we're using a map, we could do h.clients, and then client, and then we just want to pass through here. What did it? Oh, here's a weird thing that you're gonna have to do. We're gonna pass a channel of a channel. So we have a channel that is going to be taking you're going to pass a channel to it, and then that is going to be added to the map itself. And then same thing here. So we're going to have another one called disconnect. That's a good point. So we need to be able to handle when a client connects, we need to be able to handle how to disconnect it. So that's a good point. We don't have any way to handle like doing the shutdown process. We need to exit. So the way that since we have a grateful server, the way to close all the connections, we have to go and tell all the clients that are waiting for messages to close. And we need to be able to figure out that out. So that will be the next thing we will have to figure out, right? It's like we have to figure out a way to keep the connection, like not exit. Only exit when the client disconnects, but also exit when we're turning down the server, or the server will never shut down. So we will have to figure out how to do that too. But for now, let's just handle this case, and then we'll figure out how to handle when the client is shutting down too. I'm sorry, when the server is shutting down. And let's make this more helpful. So just call this client connect. And then yeah, that could be it. Yeah, we could have an event called disconnect, and then in the for loop we could listen for that too. So we will have to, let's do that. So we could do disconnect here, and disconnect itself is just a channel and just boolean. So the client itself will be so when we build the endpoint itself, the endpoint itself will have a for loop that is constantly looking for messages inside of this channel here. So this channel here is going to be listening for messages, And then it's also going to be listening for disconnect message. So when the server is disconnecting, we will send an event here. So as part of this work here, I could do that. And then here I just pass true. It doesn't really matter. I could pass false here. But ideally you want to pass something that is very helpful for you to understand what it does. Okay, so here I'm saying that when a client connects, sorry, when we're shutting down the server, we should also put into the queue, we should also just send a message into the disconnect channel. And then all the clients will be listening for this too to handle it. So I rename this to client connects. So then we still have client connects, and then we have client client equals h.client, and then when the client disconnects, right, the thing that we want to do is that we want to delete it from the object, from the map itself. So you want to be able to delete it, and then you want to also close the connection for that map. So the way you do that in Go is by passing, I think you pass, so you have a delete function, and then you pass the map, and then you pass the key for that map. So in our case, the map is clients, and then here the client is just this here. And then, so okay, so we have that. The other thing that we have to do is just close all the channels. So we want to make sure that we close our channels, because if we don't close the channel, it's just going to keep it open. Let's say that the program keeps running, it will just keep it open. In that case, we also have to close every other channel. So let's see. So this function will exit when close gets called. So maybe let's instead do this. So let's create a new function and just call it shutdown. And here shutdown will just shut down the server. So to shut down the server, we have to send a shutdown message. Wait. Okay. One thing to keep in mind, Go, is like you cannot really name your fields the same as your methods, because then it will just do some weird stuff. So there is shutdown. Cool. And then for shutdown, I want to be just thanks. Yeah. You know you're gonna miss those typos. Okay, so for shutdown, I want to be able to do, I'm gonna pass it, and then we have some, let's see what channels we have to close. So we want to close the message channel. I want to close the message channel, and we want to close the, no, I don't think we should close the disconnect channel here. We could try it. Let's just close it here for now. So disconnect, and then I'm gonna let the clients themselves, like anything that is listening, I'm gonna let them handle their own channels, like closing their own channels. So we close that channel, and the last one that we have to close is the shutdown channel. Let's see. Okay, so I'm closing messages, disconnect. There's more. There is close that H. There is the client one. So we have this one. And wait. So if we let the client connect themselves, we could close their channels here. That's what I would do. So let's do that. So let's close the client connections here too. So we close the connections here, and then we could just if we go through every client, we could disconnect them ourselves. But then, let's see. Client disconnects. Let's just close that channel. And then do close that. Client connects. So we're closing that channel. So we have now. I think we now have everything. So we have that one here, here, here. Okay. So let's see if this works correctly. So the way this works is that we call shutdown. It's gonna close the channel. The last thing we need to do is we need to build the next just a new stream, and here let's see. Yeah, so ideally you want to close them right away. Like, the reason you close them is if your program is going to keep going for a long time, because they will not be closed or garbage collected. So channels themselves are just like not being garbage collected at all. Because we want to make sure that the channels themselves are closed and the memory is returned, we want to make sure that we close them every time. If you forget to close them and your program shuts down, there's nothing bad about it. If you are doing something and then your program doesn't shut down, but you still use the channel and you leave it open, it will just continue being in memory. So the channels themselves live in the heap, so the memory itself will not be returned until you return it. That would be the only thing, which is the only bad thing. Cool. So now I'm gonna create a class to initialize the channel and return a pointer to it. Yeah, it's pretty much that. Well, it's only for the channels. Like, pretty much. Well, sorry, it's not only for the channels. It's pretty much anything that you uses resources. You have to deallocate those resources. Sometimes the language itself handles it for you automatically. Sometimes it doesn't. In the case of the channels, it's because the language doesn't know when the channel is not being used anymore. You have to close it. It's the same thing with file decryptor. So let's say you open a file, but you never close it. The file is going to always be open if the program never ends. So that's kind of the idea here. Cool. So here comes the fun part. So the fun part here is that we need to use make. So we have to allocate memory to be able to handle the fields themselves. So make, and then so the thing with channels is that they could act like buffers too. So you could be like, hey, this channel is gonna hold this many events, and then it won't block until the queue itself gets full. So it could be cool to do that, but I think we're only gonna get like 1 or 2 messages at a time. So we don't need to make it into a like, we don't have to. So you could do like 1 here. So that means that this channel here is gonna be able to handle. It's not gonna block until there's 1 message in it. So you could think of channels as a queue too, which is like, it won't block until until it gets full. But we want it to block, so we just do 1. So that means that when it hits into message, it's gonna block for a bit. But since we're using a select, it's just gonna look at all of them at once. And then we have to also create a map for client. So the client will be map. So again, setup. So we just have to continue doing that over and over again until we finish declaring it. The reason why I made a new stream function is because I don't want to do that every single time. To create a new stream, I just have to call the new stream function, and that function will return the handler for it. Sounds good. I hope you like it. Just like, I like it a lot, and if you need any help, let me know. Yeah. So then the next one will be like client connects, and then this one will be, it's just pretty much the same thing over and over again. which becomes very bit repetitive, but we just ought to do it only once. We just have to declare like the different like allocation for the memory, and then we are able to allocate that memory and then same information to the channels to it. So here I can just continue doing that. And then next ones are disconnect. This takes a make. So we might not get to start building the server itself. If we not, I'll be around tomorrow to be able to finish it up. Connect. The last one is shut down. Okay. So one thing to do here that I think we should start go routine here. So let's do that. If we start go routine here, I don't have to do it anywhere else, and that means that we know that every time I call this, it's just gonna be a go routine. And then we could make it to I don't think I have to wait for it, because the server itself, the HTTP server itself is gonna block, so I don't think this one has to block now. So the way it will work here is now I can just do something like stream, and then stream. So I'm starting new, I'm initializing the class. Sorry, not a class, the structure. And now I need to figure out how to pass it to the server itself. So whatever the handler is gonna be. So let's just create a let's look at the mutex setup and see how it goes. See if there's any way, like, what would you pass to it? So So maybe we could just make a new structure, a new struct that has a handler in it, and then I could take the riders and then pass it, and as well just pass the stream to it. So it will look something like, let's just rename the struct. I think it should just be called string. So for now, I'm just going with one file because I don't want to spend a lot of time like figuring out how to structure it. After I get it to work, I will go back and structure it in a better way. Like make this struct could be its own package, and then we could just have it as its own package. So we have that. So let's just create a new struct, just call. We could call it, let's just do hunt for now. And then in here, we could have a event. And then inside of event, we could have, it's gonna be type stream. So that means that when we create a new handler and we pass it down to this server serve mux, it's just gonna use that. It's gonna pass it as well. So we could use it as part of the logic. Okay, so we have events, and then here we just have to create a serve function. So the way it works is that as long as you have this serve HTTP function in it, and as part of the it's part of the interface. So as long as you declare this function, you could feed that, you could feed your own structures into the request handler. So here we could do. Also, I have to go back and change the names for the variable because H doesn't make sense anymore. And then serve HTTP. Let me make sure it's okay. And then that function returns term. Cool. So it doesn't return. Oh, I see. It does return. Let's see if we can find an example. Well, yeah, so it doesn't really return anything. So we could just do as long as we pass the necessary headers, so as long as we pass the writer, so I usually call let me make sure that the order is correct. So I always forget the order. Okay, that's right, and then request is a pointer. Cool. And for now, that I could just print something like works. And then as where's the writer part? Yeah. Cool. Writer, and then I could just write something to it. Want to make sure that works, and then we can just get rid of this for now. And then here we could just do next and see which one. So first we have to initialize this. Let's just initialize it for it's called H. Oh wait, I do need that. So we could do H and then handler. Then we could pass the event to it. So we could do event and stream to it. Let's just do this. Cool. So that should work. And now let's see. Oh, this needs to be a pointer. So we have a pointer to the stream being passed into the handler struct, and then we get them the handler struct, and then we could do handler does. I think we use this one here. Let's see. So this one here takes a pattern and then takes a function, and this one here takes a handler. That's the one that we want. I think we want this one here. Takes a handler, what we have, and then it takes the handler and uses it. So let's try that. So handler, and then handle, and then it takes a path. So it could be, let's say, just call it events for now. Events, and then we pass age to it. Let's see. So it's saying that it's missing HTTP. Spell it. No, I don't think I misspelled it. It's most likely it's because it's not a pointer. Yep. So usually you have to pass it. The way that this function works is an interface, and since it's an interface, you have to use a pointer. Especially because I'm using a pointer. So if I wasn't using a pointer here, sorry, if I was not using a pointer here, it should have worked. But because I'm using a pointer there, I have to ask for a point. I have to convert this struct into a pointer. I have to ask for a pointer, and then I could fit it there. So let's see what happens when I try to build this. So I have it running already. I have the server running in the background, so I have to turn it off. Cool. So that looks like it compiled correctly. So cool. And then if I go to events, yeah, weird. So that doesn't work. Why didn't it work? So I have events. I'm passing the events. What did I miss? Let's just events handler passing a path to echo events. Are all path broke, but this still works. I wonder if it's something to do with how I use him. Handler, and then should be working. Like this should work, unless I have to add it. Do I have a no? Better yet, let's just do nothing, if that works. And then we can just figure out if like something weird with the paths. No, something to do with how I have it set up. So look at this and a sample for it. So I haven't used mocks before, because most of the time I just straight up just jump into using I just directly start using ACP route. But in this case, like I think it's easier for us just to stick with it and see how far we could get by using just some of the standard libraries. So handle, is it because let's just try with the easier one. So I think you could do, so we could do this one. see if it's something to do with like how I'm feeding into the server class that I have above. So just this here, and then we just pass it as a function. So let's just, so I'm just seeing like which part is I'm having, like I messed up, so I could go back and like figure out. So here I'm gonna pass the writer, and then I'm just gonna print the world. Cool. And then you're gonna restart it. Okay, that works. Cool. So that means that I'm doing something that I shouldn't be doing here. So let's see what that is. Okay, so this works. This is the example that doesn't work. So let's try something easier. Let's see what this is doing. So send a pointer, since it's not using it, since it's not using the variable, it's just like straight up just ignoring it. So let's just try that. So we're not using it yet, so we can just do this. And then since we're not using it, we don't have to pass as a pointer. So let's change here, and let's just add another one. So let's copy this one, and then here something like events again, and change here to use handle. We don't need this yet. We're going to go with the simple case first, and then make it more complex as we go. For now, we're just gonna stick with the event. Then we're gonna feed the struct directly into it. So we're gonna do handler. We're gonna feed it there, and then I'm gonna go back here, turn it back on. So we recompile it and we try it again. That one still works because we didn't take it off. The events. The events is working. Okay. So, oh, it was because it was a pointer itself. So maybe I'm not able to use. I thought I could use pointers for the handler, which is this is a pointer here. Well, it's taking a pointer. Yeah, I thought I could do this. Let's try it out. So now if I turn this into a pointer receiver, I could go here, say that it's going to be a pointer. Okay, so if this still works, we go back, refresh, it works. Second. So I am looking at shot this. Nope. Sorry about that. Okay, so we're back to figuring out this. Okay, so this works. So I wonder what I was doing here that broke it. So we could even do we could just do this, something like this, and then try it again. See if that worked. Maybe the compiler was not building it correctly. Yeah, that works. I'm not sure what was going on. It could have been something to do with the compiler and how it worked. Like it was doing some kind of work or anything like that, and you just got stuck or something. And then cool. So yeah, so this, what if I just go back to using this here? So let's just change this back to where it was, and it looks the same. So let's see. Now and then same next handle events, and then we're gonna pass h to it. Cool. Let's try this again. Recompile and rerun it. I did, yeah. I'm not sure if you know this, but there's a moderating tool. So when you go to the chat, sorry, when you're watching the stream, if you're a moderator, in the bottom corner where next to chat, like where it says chat, and then there's a gear, then there's a sword. If you press in the sword, you get a cool view. And then that view there, you are able to moderate. Like you're able to slow down people, or you're able to put people in timeout, pretty much. And then if you click on the person's name, you could ban them in real time, or slow them down. Like if someone is like really spamming, you could do it. Yeah, it pointed me out like when I was yesterday. So yesterday I did a stream for League. So a group of us were playing Clash. So we ended up doing a stream there. And then part of that stream I was testing out like they would set up on my other computer. But it came down to like it showed me that sword. Okay, so now it's working. It just, so for instance, didn't like what I was doing, but now it's just like it just works. So I just want to make sure that it's really updating when I'm changing my code. It is. Okay. That was very weird because I didn't change much. I don't think I changed anything specific. I did maybe, not sure what I did. Okay, so that works. Let's go, that works. Cool. So that works. So here I could just do, I need to make the stream a variable so I could use it to start it. Okay, so it started, and it's now a variable, so I could just do stream. And then here I could just go here and then go stream that run. Probably rename it to start, but let's just go with run for now. Cool. And then let's just put some lagging, so we make sure that we're printing something as this goes. So for now, I'm just gonna use print statement, and I'm gonna do starting stream, starting event stream. Stream, and then here I'm gonna add sending message to client. Cool. Let's just do a couple more of those. So let's do connecting. So this will help us in case there is a step that is missing. So we could go back and be like, okay, so I was expecting this to print, but it's not printing. So that means that it's not coming to the console. So you can ask, it never got triggered. So it makes it a lot easier for us to go back. And then, so let's see. new client, connecting. And then here we could go with client disconnecting. So we could just remove these messages later or figure out how to do some kind of better messaging, like use something like log or something like that. But for now, this is good. And then here we could just do event stream starting. Okay. Cool. So starting down, and now when we rerun it again, we should just see it starting up. Yeah, so it started. So that means that it's getting events. And a way to test this is that we could just do, so here we could add a new client. So let's do client and then make. So we're going to make a new channel here. And it's a channel that we're going to send into the event stream. We could do string. So we're expecting the client to be stream. String, and then here we could do handler event that client connected. Right, so the client connected, disconnected, connected, and then we're just gonna pass a client to it. Cool. So now we're just like passing a client to it. So the way that we should see it we should see it starting, which is the one we saw before. And now when we make a request, we should see the client being added to the client list, because we're maybe we should also disconnect it. So we should see two of them. We should see it connecting, and then we should see it disconnecting. Yeah, so now the client is connecting, and then we should see a disconnect of the client as part of this. So let's start that. And if we started our memory correctly, we shouldn't see a panic when we refresh. Yeah, so we still have panic. So because the channel close is just panicking. So it just panicked. So this is what happens when you don't handle it. So if you try to write to a channel that is closed, it just panics. So there is somewhere that I'm closing the channel. So yeah, I close the channel and it's like complaining because I'm trying to close a channel that is closed. So I think the issue here, why would it panic? Okay, so we remove the client. Also, you have to learn how to read these things, because sometimes it tells you which line was the one that panicked. So 36 was the one that did it. Okay, so 36 says, oops. So 36 says that, okay, so the channel itself was closed. Where was it closed? I didn't close it myself. Oh, it's because, no, it's because I deleted it? No, that wouldn't do it. Okay, so for now, maybe because I'm doing like back to back. I'm sending the event and then I'm closing it, so that might just make it confused. For now, I'm just gonna say that the disconnect works. Oh wait, line 32. Oh, yeah, thanks, copy and pasting. You're right, yeah, it's because of that. So the error was because when the client connected, I was also closing the channel. So that definitely makes sense why it was closing. Yeah. So if you try to write to a channel that is closed, the application itself will panic. I believe there's ways to handle it. I'm not sure if the close. Let's see. I think the close function returns. No. What if it's closed already? Let's see. Try this one. I have some good samples. Oh, okay. So if the channel is closed, the way to check if the channel is closed is by, so it returns a, so first value is the value, and then returns okay if the value is closed. So the way to check if it's closed is by checking if the value, like what value came through it. Cool. So let's back to this here. Okay, so the channel works. Now the next thing I want to do is like, I want to listen. So I'm gonna do a for loop, same as the one before, and then I'm gonna press select. So I'm just gonna loop through this, and then I'm gonna do a case. So the case here will be message and then client. So the goal here will be to get a message and pass a message, so somehow pass a message into the stream, and then get a message back. So we're gonna get the message back, and when we get the message back, we could then we should just print it out. So this is kind of like getting us in a good place where we could start testing some of the code that we wrote above. So we could just do that. And then so now we have to do the disconnect. So for the disconnect, I was gonna just do so when we're shutting down. I wonder if I need to do so many bands. I mean, so many channels. Maybe I could reuse them. So I could just probably do. What if instead I just change this a bit? So I could probably listen to the shutdown event, or no, let's do, yeah, let's just go with this one for now. I'm leaking a bit of the abstraction because I don't want to depend so much in so some of the methods, sorry, some of the fields on the that I created in the stream struct might not be available. So I want they're private in the first place, so I don't want to depend on them too much. So I want to just probably gonna end up using this one for now to make sure that I could shut it down. So I'm gonna shut it down like this, but I might end up changing this down the line. So I'm gonna return. And then since I'm returning here, I should also close client. And this code is not anymore. Okay, so the way it's gonna work is that I'm gonna listen for a event, and then when I get an event, I'm gonna print that event back out. And then if I get a shutdown signal, I'm then gonna shut down. The thing I will need to figure out is how to handle this shutdown. Like, oh, I think I know. Okay, for now, since we're gonna kill it anyways, it doesn't really matter if it shuts down correctly or not. But we will backtrack and kill it. Okay, so we have this now. Now the next thing I will need to figure out is like, how do we test this? So I haven't written any tests. So I might just end up creating another endpoint. So, oh yeah, so here, let's just reuse this one. Okay, so we're gonna reuse this one. Here we could just do stream that message, and we're gonna pass hello world to it. And then here, since I have hello world, so the goal is that every time I go to the home page, so every time I go to slash, it's gonna trigger an event, and then Now the question that I have, well, this might not work as I wanted it to work. Well, it's gonna loop forever, so that means I will never get a response back. Let's just, this is not gonna work. So for now, I'm just gonna print it into the logs. Okay, so I'm getting a message, then I'm printing it to the console. When I open the events endpoint, I will never get a response, and the connection would stay open forever. And then since the connection is open, gonna be open forever. That means when I go to slash, I should be able to see the output in the console. So let's see if that works correctly. Okay, cool. So let's just create a new tab here. So you send an event, then I refresh it. Oh. Yeah, so you don't have to. So so it's looping forever. It's printing something. I don't know what it's printing, so I have to look into it. Oh wait. Okay, can I close it? Okay, that was bad. So one thing that you will see a lot in Go is the use of, to answer your question, is the use of okay, so you don't have to use it. So you can, but so like I don't need to check that the channel is open or not. In this case, the channel is open because I'm getting a message out of it. When it becomes useful, the useful part of using OK for the second value is when you try to get things out of a like when you're trying to get things out of a map. So you could do like something like let's see. Let's say that you want to check if the client is in the map before you delete it. So you want to check if the client is in the map before you delete it. So you would do something like if so you would do value, or in this case I don't really care about the value, so I could just do OK, and I could do so you could do something like this, right? Where you're like, oh, I want to check if this value exists, right? Whatever key I pass to it, you could check out if the key exists in the map. And you could discard. So underscore discards the value. So you're saying, I don't really care about the value of this key. I only want to know if the key exists in the map. And then if it exists in the map, you're going to get a OK is just going to be like true. And then you could do something other logic like found client or something like that. But yeah, so in some cases you have to ignore it. The ones you're never supposed to ignore is like if you do something like error. So let's say that I'm making JSON or something, marshalling JSON or anything like that, I shouldn't ignore it at all. But yeah, in our case, we don't need to check if the channel is open or not. So I think I did something bad here because it was printing to the console, but I don't know what it was printing. So I just want to make sure that it was here. So best tool for debugging in pretty much any language is just printing to the console. It's my go-to. Okay, so for some reason it's going there. Let's just kill this. What is it? But it's not getting anything. So what am I doing wrong here? Unless the one on the top. No, the one on the top is having fire. So I am doing something weird here. So I'm passing the client. So I just want to make sure that I'm not doing like something wonky. I think I am doing something wonky when it comes to the channel itself when I'm listening to it. Maybe I shouldn't use, maybe I don't need select here or something like that. Maybe I just need to just listen for the event. But then, okay, so we're listening for the event only. So this means it's gonna block. And we don't need this. And here, it's gonna loop forever. So for now, See what happens here. Yep. Let's try this again. Cool. Then refresh. Yeah, some reason the channel is being, it has the information. I wonder if it's like how I'm making it. Let's see. How am I, like, what is the weird thing I'm doing with this channel? What am I doing weird? So I'm making the channel on line 70. The only thing that will be, I wonder if it's, let me just get rid of, oh, you know what? It's because I'm closing the channel. So when you close the channel is closed. Oh, this is a perfect case for you, Bobby. So here, this will have saved me a headache. Okay, because I ignore, okay, the channel is closed. So if I refresh, wait, did I remove it? No, I didn't remove it. Okay, so the channel, I'm closing the channel in the line above, and because it's closed, I'm just getting, it's failing. Yeah, so if I had the okay, I would know that, I would see that, oh, well, what am I getting false for? Well, I'm getting false because the channel is closed. Okay, so the channel is false. So that means I just have to get rid of this thing here. Okay, let's just go back a bit. So okay, so we could go back a bit, and then here we could do okay, let's get rid of that for now. The message is depends, because I'm using an integer, sorry, a string. It's just an empty string. So in Go, a nil is just a pointer. So you only get nil when you use pointers. If the struct is just not a pointer, so if you don't have a pointer to the struct, you get a empty struct, which is the comparison. So most of the time you want to use a pointer to compare structs if the struct is nil or not. Sorry, if the struct is empty or not. But yeah, so Go has a set of default values for its for everything. So integers is 0, for pointers is null, and for strings is empty quotes. Sorry, empty string. Okay, so let's see how this goes. Also, let's see. Okay, so we refresh. So the new client connected, and because we're not killing the connection, it's gonna keep going. And then we go here, and then cool, it works. So we're getting an event. Okay, so if I refresh this a bunch of times, so okay, to highlight what is going on. So I hijack the just slash to be able to send an event to be able to test the event stream struct that I created above. So I created that, so now I'm able to just send events to it. So I send an event, and then that event gets captured. It goes here, and so in this for loop, which is this page here, which is looping forever because I'm not returning anything to it just yet. So I'm sending that there, so it's looping forever. Then it so here is gets the event, and then it just prints test, and then prints the event itself. Cool. So the next thing we have to do is like figure out how to send the necessary information that we need to send. So this is PHP. We're not doing it in PHP, so we're gonna have to figure out how to do it in the Go way. So the thing that we need to figure out first is how to set headers. How do we set the necessary headers to let the browser know first that we don't want to cache this? So whatever request goes to this endpoint should never be cached. And then the next one we want to do is that we want to set the content type for this endpoint to be text/event stream, which then we could start using it for JavaScript. From the JavaScript side. So for Go, I need to figure out how to do the headers because I forgot. So I think it's so I think the way you do it is like you do rw headers set, and then you go like that from there. But let's see. So this is for the HTTP one. So let's see how do we do it from the server side. Let's just try it, see how it goes. So here I want to be able to just do headers. So we have access to the header method here, and then we just do that. Wait, right? Okay, let's see if this does. Okay, so it's the method itself. So you're calling the header method, and then the header method returns the headers, and then you have to set it here. So here we want to be able to do. If you're wondering why I'm using double quotes, if you haven't done Go before, in Go, single quotes are bits. So it's like single characters. So you could do that. So you always have to use, for regular strings, you have to use double quotes. Okay, so add header takes two things. So it takes the header name. So in this case, it will be cache controller, and then we want the value for that to be no cache. Cool. And then the next one that we want to do is the content type. So let's do content type, and event. Cool. So we are setting the necessary headers in this case. So we're telling Go that, sorry, we're telling the browser that this is not cache, this endpoint should not be cache, and we're telling it that the content type of this endpoint that it's going to be returning as an event stream, just with text. So now the next thing that we have to figure out is how to do a flush in Go. So here's pretty much how you do it in PHP. So every time we have an event, so the way it will work is that every time we have an event and we print it into, and we echo it out, we send it to the client, we also have to flush it, because the way that HTTP works is that you don't flush, like it's not constantly sending the events, you have to, it like buffers them and then sends it all at once. The thing that we want to do is just every time we get a event, we want to just flush it straight to the client. So we're going to do that next. Cool. So for that, I need to figure out how to do flush. So let's see if there's anything here that is flush. Okay, so there is a type called flusher. So we just need to see if there's like an example of how to use it. So flusher is an interface. See, flusher. So it has an interface that does like flushing. So we just need to figure out how to, like, what is the flushing interface? So we figure out the flushing interface, and then we can just use that flushing interface to send the requests. And that will make it a lot easier. Okay, so I think, so let's see if we can find an example. So flusher itself. So if I can ever find anything, the best place to find examples is a Go code base. So in the Go code base, you could just go and just like search for like, so in the Go code base, you could go and search for anything that you were looking for. What is the search for? Oh. So yeah, so let's see if there's any samples of flusher. Okay, so this is for reverse proxy, but it looks like you just take the writer. It's a writer. Oh, it's a flusher writer. Okay. Let's just keep looking. Okay, so this one is a HTTP one. Cool. So it looks like we just turn. So W. Okay, so the response. Okay, so here we could just do something like that. So we're converting this to a flusher. So I think it's HTTP.flusher. Yeah, so we're turning this into this interface. So we're so this is how you cast things in Go. So I'm casting the HTTP response writer to a flusher, and then I could just do that flush here. And because I renamed it something else, it's called RW. So okay, so RW is a flusher. So okay, so now we figure out how to do the flushing. So now we could just take that. It's something to do with like so it's the same way in C++ and C. It's mostly like it's just how that. So the thing that happens in Go is that you could create it. You have like the chars and cells, so you have the characters and cells, and then you use single quotes for those single characters, and then those single characters are just these characters. All around what? So those single characters are just this here. So it's just like default characters. So you could that's an easier way for them to write it, and they take only like I think they could be wrong, but I think they take 1 bit of space in memory when you use that. There's a lot. So the way to think about it, there is a lot of work to be done if you use double quotes, because the thing with Go is supports other languages too. So it's not only English. You could do Japanese, Chinese. So you could take Chinese characters and you could yeah, and then you could just create strings out of them. They're not they're not single characters. They're runs. So in Go there's a concept of runs, and those are just like a set of different characters, right? So like you could have different languages and like so the main goal is like to differentiate between them. So for example, you could do like things like this. So that's one of the benefits from it. Yeah, so check that link out. Okay, so we now have the flush. So we have flush. Also, I have I gave a workshop a while back. So I have a workshop that I did a while back that goes into details around it. Let's see if I could find it. Okay, yeah, so I did a workshop a while back that explains like the difference between here, I will not look at it now, but you could just go through it. You could run it yourself too, if you need some help too. But it's also just run this command here, and you are able to just run through the presentation. There is also speaker notes too. So when you open it, it's gonna open the speaker notes. So that will help. Cool. So okay, so back to it. So I have this. So now we should just print something. Let's just do the format that we need to do for printing. So to print, we will do we're gonna use this here, and then we're gonna do, because we need to add a new line, just let's use the new line one. So we do RW, and then here we just do event ping slash. Oh, we don't need the ends because we're using so when you do ln, it adds a new line, so it's just adding a new line at the end, so we don't have to do it there. So let's see, current time, we don't need that. So then we just need to pass the data. So data could be anything in this case. So for us, we're just gonna use hello world. So let's make sure, let's see. Okay, so I need one new line. So this one will add a new line, and then here we do data, and then inside of data you want to do see if this works, hello world. Okay, so let's close this. Okay, so we now have one, we're missing one new line, so we could just do an empty or we can just print it. Let's just print it so we don't confuse ourselves. F print, and then just gonna use the regular one. So rw. Cool. I think he has. I think he has before. He was telling me that he had one before for a friend of his, and he was a moderator for it. So he has superpowers now too. Don't abuse them. Don't abuse him. Oh, I need to close this. So you can see, like, because we have our server is like graceful. Even if I try to exit out of it a couple of times, it just like doesn't exit until I force it to exit. Okay, so we're listening for event, then we go here. So that works. We were able to. So this is a mistake that I did. I passed a run to it when it's supposed to be a new string. Okay, so it works now. So we could get constant events. So if I refresh here, we're gonna get some more events. Let's just restart it. So you see, I could just continue just like going because the request is not closed. It's just gonna take forever. It's gonna time out. So that's what you're seeing. You're seeing the timeout from the server happening because nothing is closing. Okay, cool. So I refresh, and the event gets added. I see hello world. I refresh again, and I get another event. So this is pretty much what we were building. So this is kind of like the where we're going. So that means like I could use JavaScript to connect right now too. So let's do that in this side here. So we could just use JavaScript to connect to it and see if it works. And then that will be the stream for today. For which server? For the Grateful server? Yeah. So let's see. So I don't think you can configure it here. I didn't not make it available as I think I didn't make it available, but it's part of this library here. So to make it available, let's see if it's configurable. So shut down. So right now it's not configurable. So it's gonna wait like 5 seconds, and then if it doesn't happen in 5 seconds, this is gonna kill it. I should probably make this configurable. So I will just leave a comment for myself. Oh. That's fine. So here I'm just gonna leave myself a comment to make this configurable because it should be nice to be able to configure. Yeah, so that's how it kind of does it. So it's hard coded to 5 seconds. Let's go back a couple times. Good. Cool. So we're back here. So we wanted to connect to it using JavaScript. So let's just use some JavaScript to connect to it. So to connect to our stream using JavaScript, we need to create, we're gonna use this, but we have to change the endpoint to make sure that it matches our endpoint. So it's gonna be /events. So we do connect to the /events. Why did it refuse? Oh wait, is it running? Nope, it's not running. That's why it refused. Okay. Cool. So /events. I have to give it a different name. Let's call it events for now. Cool. I don't want to restart session. So events, and then we just could connect to here. So that, and change this to DVD, and then here we can just do console.log. Okay, so we're using JavaScript to connect to the event side of things. So because our event name is ping, so back to the code. So when we write to the client, we're writing a event type ping, and then we pass in the data, just hello world to it. So let's see if this works. So now, okay, I'm gonna put this here, and then I have to open a new tab. So let's just reuse this one here. If I go here, it should trigger an event. So yeah, so it worked. So we got an event, and now we have the data here. So if I wanted to get access to that data, so let's just refresh this, so I could lose the session. So I open the connection, then I go here, and I could do that data, then press enter, and I refresh, then we get hello world. So that means that we could get events in real time. So if I continue refreshing this page over and over again, you could see how the counter here is going on. Yeah, thank you so much for watching. It was nice to get some server-side events going. So I will be streaming tomorrow, the next part of it, which is just using HTML and using JSON and being able to just build like a nice follower UI as it goes. Also, I will be streaming some gaming tonight to follow the channel motto here is coding by day, gaming by night. So today around like 6:30, 7, I will be streaming some games as well as part of the stream. But thank you so much for watching, and I will see you guys later.